15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello, thank you for joining us on Space Nuts, a show about astronomy, space science and stuff, all sorts of stuff. And we've got a lot of stuff to talk about today. It's a jam-packed program, and we could probably do 2 programs with this much material. And you can see how professionally I've prepared the run sheet. We're going to be looking at the Russian missile test that has certainly caused a few problems on the International Space Station. It seems every other week something's happening with the ISS. I think they probably weren't too worried about the blocked toilet problem now that this has happened. There's a new dark matter theory that's been published, and we'll talk about that. Also, the discovery of a small black hole beyond our galaxy. It's not far outside our galaxy, but it's there. What does that mean? And we're going to answer questions about, I love this one that comes from Sweden. Can we nuke Venus and reverse the runaway greenhouse effect? I hope so. Also, life on Mars. And we've received a photo from Rusty in Western Australia, which is a photo of the moon with this beautiful halo around it. And he wanted to find out, what the effect is and why. And we will use that photo on the cover of this week's episode so you can see what he's talking about. So we have plenty to talk about today on Space Nuts. I am Andrew Dunkley. I'm your host, and joining me, as always, every week is Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. Especially wearing my Space Nuts sweatshirt today. Look at that.
I'm wearing mine too.
Oh, ta-da!
Yay! It's just a bit colder here, so I'm wearing a jumper. It's freezing. This has got to be the coldest November I think I've ever experienced out west. So I don't know what's changed this year. Global cooling, perhaps. I don't know. It's been a very cold, wet winter and spring. So yes, hopefully we'll get some warm weather soon.
But it's definitely not global cooling, Andrew.
No, definitely not. Now let's firstly talk about this Russian missile test. It was described as an anti-satellite test. But the problem with it is it's caused some debris, which caused a little bit of a panic with the International Space Station. What happened?
Yeah, so exactly as you've said, this is something we didn't expect. It was basically a surface-to-space missile, which was fired by the Russian military into one of its own satellites on Monday this week. And it was basically a test to see, I'm sure it was to see whether they could hit it, and it did. But it's been widely condemned because of the debris field that it's generated. At least 1,500 particles big enough to track, and many other smaller pieces of debris, probably thousands, hundreds of thousands of smaller fragments. And it's really, what's bizarre about it is that the missile was aimed at a satellite that is in an orbit just a little bit higher than the International Space Station's orbit, which is about 400 kilometers above the Earth. And the expectation now is that the debris field from this spacecraft will spread out, and the space station will pass through it or near it every time it orbits, which is every 90 minutes. However, after I think they spent something like three orbits or 3 passes of the debris field, the NASA kind of mission control for the space station determined that it was safe to actually set the crew back into the main interior of the space station, because they were all sent to their lifeboat stations, which are the spacecraft that are permanently docked with the space station to bring crew back home in case of an emergency like this. However, I think, as I understand it, there are still several of the modules of the space station are being sealed off. And I guess what they're doing is just shutting down the amount of volume that you need to keep a decent atmosphere in, just in case one of these modules gets hit. So if it's sealed, that's less of a problem.
That's pretty scary, Fred. And got to bear in mind that 2 of the astronauts on the ISS are Russian.
Are Russian, yes, that's right.
So I don't think there was anything malicious in it, but it's certainly drawn the wrath of the US government. They have been scathing in their criticism of this. And, I think they've got a point. Nobody knew this was coming. And it sort of beggars belief that you just go and shoot something in the sky and not think about the consequences. Maybe they did, but it's a real mystery. And, space is just going to get busier and busier. And we need to have room up there. And you don't want to really have all this junk flying around out of control and getting in the way. There was one suggestion that this could set back future space exploration or future business around the planet by many years.
Well, that's the length of time that they're talking about the orbits of these particles decaying in, years or decades, so that they will eventually come back to Earth, because even though it's effectively a vacuum out there, there's still a little bit of atmosphere at the height of the space station. It's enough to slow down the space station, so they've got to keep boosting it up to a higher orbit, and it will eventually cause this debris field to decay. But yes, it's been, I think, greeted by all the commentators I've heard and read, but with incredulity. What on earth were they thinking of? And I would imagine, and this is me now reading between the lines, but Roscosmos, the Russian space agency, are probably also saying, what on earth were you thinking of? Yeah. Because we get the impression... No, it wasn't them. It was the military. Maybe, there aren't particularly good links between the two, essentially Russian government agencies. I don't want to speculate any further than that, but it has been greeted with surprise. And we think at the moment there's no immediate threat to the astronauts on board the space station, but there could be just one of these bits of debris ploughing into, one of the modules, punctures the space station. What
we need to do is send Sandra Bullock up there. So
yes, that's right.
Yeah,
yes.
She'll sort it all out. She's pretty good at that.
Apparently.
All right. Well, we'll watch with interest. Could it mean at some stage they might have to move the space station permanently into a different orbit?
Probably not, because it's such a big object, changing its orbit at all. And they do... probably once or twice a year, they have to change its orbit slightly to avoid potential collision with tracked bits of debris. But to change its orbit significantly, like to put it up to 600 kilometers or something like that, that's in engineering that I think is beyond its capabilities at the moment.
Wow.
Just because you'd need such a big booster rocket to do that, given the amount of material that's up there.
All right. Well, hopefully it will not become an ongoing threat, but yes, a lot of heads shaking and fingers wagging.
Yeah, exactly. That's right.
At the political level. All right. If there's more to report on that down the track, we will certainly let you know. Now, to this fascinating story, and I've read some reports to suggest that this is also a little bit scary, the publishing of a new dark matter theory. What are they proposing, Fred?
Yeah, I confess that I haven't really gone deeply into the details of this. It's a paper published in Physical Review Letters, which is a very eminent journal. And this is basically an international team of physicists from many different institutions. And it's really an addition to or a modification of dark matter theory, such as it is, because we don't know what dark matter is. It's we know it's there. We think it's some sort of subatomic particle that permeates not all of space, but it likes to be where normal matter is, and that's how galaxies don't fly apart and all the rest of it, as we've talked about many times. But this new theory suggests that dark matter actually originated in normal matter. And that's the new part of it, because the theory as it stands at the moment is that dark matter was created essentially in the Big Bang, or in the aftermath of the Big Bang. The research that's been done already all has the idea that some fraction of what was created in the Big Bang was dark matter, as part of this thing that's sometimes called a thermal bath. And it's where basically there was this, this superheated plasma, if I can put it that way, which formed dark matter particles. And that's so the idea is, I'm sorry, I'm not making this very clear, but the idea is that dark matter came into beginning independent of normal matter right at the beginning, right at the time when the Big Bang occurred. But the new theory, has some sort of mechanism in it that creates dark matter from normal matter. And that then begs the question, if you accept that as part of the theory, okay, so why is there nothing? Why is the universe not made completely of dark matter? Because if normal matter turns
someone would ask that question, straight away.
You might have had it in the back of your mind at the beginning of this, and that clearly hasn't happened. And what they're saying is it hasn't happened because the universe went through this period in the first gazillionth of a second, which we call the inflation epoch, or the inflation period, when its size changed from being the size of a pinhead to the size of a galaxy in 10 to the minus 33 of a second. I can't remember the details, but it's that kind of thing. It's just mind-blowing stuff. And what they're saying is that because of that expansion, then dark matter was the process of changing normal matter into dark matter was inhibited. There was some sort of dampener put on it, and so that's why we've only got this fraction today. And of course, normal matter is completely outweighed in the universe by dark matter. We think it's about 5 to 1, the amount of dark matter compared with the amount of normal matter. So what that suggests is that much of the normal, if this theory is correct, much of the normal matter actually became dark matter, and there's this small fraction left, this sort of 20% or thereabouts, a bit less than 20%. That's all that's left because it wasn't turned into dark matter.
It's interesting because if they're right and that happened, it's a good thing, because if dark matter didn't come into existence at the exact same time as normal matter, then we'd have a lot of normal matter in the universe now compared to what we've got at the moment. So it might have inhibited our capacity to exist.
Indeed, it might not. Things called galaxies might not have been able to hold themselves together because this mass was not there. And of course, you could equally argue that they'd hold themselves together because there's more normal matter. Because that hasn't been turned into dark matter. Anyway, all that notwithstanding, the big question, of course, is how can you test that?
Yes.
And all they're saying is that there might be what they call an observable fingerprint, some sort of signature in that great tool of cosmologists, the cosmic microwave background radiation, the flash of the Big Bang that we can still see by looking so far out into space. You're looking back 13.8 billion years, and you see this wall of radiation which has a pattern imprinted on it, which comes from what's called the baryonic acoustic oscillations, the sound waves ricocheting through the fireball. That is what tells us about the conditions within the Big Bang. We've learned a huge amount from that in the world of cosmology and understanding the origin of the universe. Maybe there is still something else that can be teased out of it that might actually indicate that perhaps dark matter does turn into normal matter. And I can sort of imagine, the kind of thing that might be, but I can't imagine how you would go ahead and find it. It would be such
I don't know either, but
yeah.
that becomes the challenge. You come up with the theory, then you've got to prove it, but you can only prove it if you can find the evidence. And yes.
Yep. So it's an interesting one. I will actually, I haven't had time to do this, but I will go and have a look at the original paper and see if I can understand it for a start. But try and make, if there's any more comments that I can make on this, then I will do.
Yes. Once you get through the 75 pages of authors.
That's right. Absolutely. Yeah.
Yeah. All right. There might be more to talk about in the future in regard to this theory. But yes, it looks like they're considering that dark matter became at the moment of the Big Bang, and it made itself out of normal matter. Yet to be proven, but it seems to be a theory with some weight. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
3, 2, 1.
Space Nuts.
Thanks for joining us, and I hope you're well. Now, I do want to mention a couple of things. First of all, that we have a YouTube channel. If you are someone who likes YouTube, go to spacenuts.com/c/spacenuts, and that's where you'll find us. And we have all our episodes on there. And, of course, in recent times, we have been providing a video version of Space Nuts on YouTube. So you can watch us as well as listen. Some of the earlier YouTube episodes are just audio, but the most recent episodes, going back a while now, are there. And we've put them in smaller chunks, so they're easier to manage. So you might find that more to your liking if you haven't got time to sit down and listen to the whole darn thing. You can watch it in small, manageable chunks. That's on YouTube, so do a search for Space Nuts Podcast. Now, Fred, we have been talking about your new book, Space Warp, but one thing that you've released along with the book is a calendar of your sketches. Now, a few people know that you're a musician, but also an artist.
Well, yes, sort of. A cartoonist might be better. So, indeed, here's the calendar, Space Warp 2022, with one of my cartoons, which is meant to depict relativity there on the cover. It's the Express meets relativity. But these are drawings, as you've said, that I did for the book. Here's the what the Trojan asteroids really look like. That's. Another one from the pages of Space Warp. But this is a calendar. It's got dates in it, and also the phases of the moon, which are printed the right way up for the southern hemisphere. So I'm sorry if people in the north would like to the right way around for the south. But
if they turn it upside down, it'd be okay, though.
That's pretty well right, yes. The calendar, I think it's about $20 Australian, which is next to nothing in US currency and pounds.
10 cents.
And Hugh will, we hope, have them available. Probably what's more likely is Hugh will put a link on the Space Nuts podcast website, and you'll be able to buy them. Actually, now this is the thing. I will sign them. I'll sign every one that goes to Space Nuts listeners. So you get the artist's signature as well.
Fantastic. All right. So spacenutspodcast.com is the place to go, or spacenuts.io, and click on the shop link. If it's not there, it will be soon. So I'll chase Hugh up because he's probably on his lounge watching the Muppets or something. That's all right.
Sorry, Hugh. Look, I apologise, Hugh, on behalf of Andrew there. He's... It's not that I know it's not the Muppets. It's Get Smart that you watch, isn't it?
Yeah, that's right. Exactly. Now, moving on. Our next topic is strangely about black holes. We never talk about those. But this story is interesting because they've discovered one, they believe, that's outside our Milky Way, but not by much, and it's a small one. So, what have they found? Why have they found it?
Yes, so this is it is a black hole outside our Milky Way galaxy because it is in the Large Magellanic Cloud, the biggest of the two. Oh, the biggest of, or the bigger of the two large dwarf galaxies that orbit our Milky Way, visible from the southern hemisphere, beautifully seen in dark regional Australian skies, as you would well know, Andrew.
Yeah.
The Large Magellanic Cloud is about 165,000 light years away from us, from our vantage point in the outer reaches of the Milky Way. The small cloud's a bit further, about 200 light years, and not only does it look smaller because it's more distant, 200,000 light years, not only does it look smaller because it's more distant, it also is smaller than the large cloud. The large cloud is, it's measured in, I think, hundreds of millions of solar masses in terms of its mass. So a well-studied object, an irregular galaxy, does have some sort of evidence of stubby spiral arms, perhaps. But there it is in our southern skies, and it has been observed by astronomers using the European Southern Observatory's very large telescope, the VLT down there, and Serra Paranal in northern Chile. And as I always mention, because the Australian government pays me and the Australian government made this arrangement, Australian astronomers have got access to that telescope, or that set of telescopes in the strategic partnership that was signed off in 2017, and they're making very good use of it. This story, however, does not come from Australian astronomers. At least one of them is from, at least one of the astronomers responsible is from the UK, Liverpool John Moores University, Saraceno. And what they've done is they've observed one of the many clusters, young clusters of stars in the LMC, the Large Magellanic Cloud, which are a little bit different from the ones we find in our own galaxy. The clusters come in two sorts, Andrew. What are called globular clusters, which are truly ancient objects, almost the age of the universe, and things called open clusters, which are a bit like the Pleiades star cluster in our night skies, not far from Orion, part of Taurus the Bull. That is an open cluster. It's rather than being a group of 500,000 stars, it's a group of maybe 1,000 stars. That will be a fairly big one. And they still have the gas, traces of the gas in them in which these stars were formed. So they're very young. They're kind of infant star, not exactly nurseries because they're the nebulae where stars are born, but they're star kindergartens, if I can put it that way. And they've studied one of these clusters, which rejoices in the name of, where has he put it? NGC 1850. There you are. That's the cluster's name. NGC, the new general catalogue, published in, I think it was 1888. It's not new anymore, but still very useful. NGC 1850. And they've studied the stars in it and found one that has a curious motion, basically. It's got blips in its movement, and the only interpretation that you can make of that information is that there is a black hole orbiting it, or the other way around, more likely, actually. So what you've got is a star in orbit around a black hole. It's about an 11th solar mass black hole, and the reason why it's an extraordinary discovery is, first of all, as you said, it's the first one discovered outside our galaxy, the first one of this sort, rather than being a supermassive black hole, which are often seen outside our galaxy. In fact, we think there's one at the middle of every other galaxy. But this is a stellar mass black hole, so kind of been formed from the debris of a dead star. So it's unusual because it's outside the galaxy, but also it is very, very young. This cluster is only about 100 million years old. That's a tiny age for a cluster like this. They are, as I said, they're the stellar kindergarten regions, and 100 million years old is actually, I guess, fairly typical of an open cluster. But it's some of them are even younger. The Pleiades are even younger than that, but most of them would be maybe 500 million years or thereabouts. So this one's a young star cluster, and it is the youngest object in which a black hole has been found. That's the record that I'm trying to get to in this long-winded explanation.
Right.
As the astronomers write themselves, no black hole has ever been discovered in a cluster that young.
Mm. So the question becomes, how did that happen?
And so it's not that surprising, really, because we know that black holes come from massive stars, and the most massive stars have the shortest lives. Their lives are measured in tens of millions of years rather than billions of years, like the sun. And so, if you had a massive star in this star nursery when it was being formed, it may well have gone through its short life very quickly, burned up its hydrogen fuel, and basically collapsed as a supernova. The core forms a black hole, and what you've got is this orbiting pair, which we wouldn't know about. The interesting thing is we wouldn't know about this black hole were it not in orbit around another star. Or the other way around, in fact.
Yeah.
And if you remember, there's been a number of stories that we've covered recently that are similar to that. People finding black holes not by the fact that they've got an accretion disk of stuff swirling around them that's being gobbled up by the black hole and releasing X-rays and radio waves, but by the fact that it's pulling another star out of kilter, if I put it that way. But this is the first time a discovery like that's been made beyond our own galaxy. It's extraordinarily good research.
Yeah, and I suppose that opens the way for perhaps finding more through various methods. But the European Southern Observatory's got the credit for this one, which is fantastic. But I mean, it's always exciting to find something new, always. And it looks like they've kind of stumbled across it, but it's there. We know they exist, and finding more probably becomes more apparent now because you've found a methodology, and there's all sorts of possibilities that come up. You said that the biggest black holes are caused by the most massive stars, and because they have the shortest lives. The same thing applies to rock and roll stars. The most massive rock and roll stars have the shortest lives too, I've noticed.
It's a very good parallel, yes. Probably similar physics involved as well.
Possibly so, yeah. They implode.
Yeah, that's right.
Yeah, all right. Well, there might be more on this one as well. So a couple of stories that have come up that we may well be able to follow up on future episodes of Space Nuts.
Indeed.
You're with Andrew Dunkley and, of course, Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
A reminder again that if you are considering becoming a patron, you can do that via our website, of course, spacenutspodcast.com or spacenuts.io, and there are supporter links there so you can look into becoming a patron. Becoming a patron is very easy. It's a small monthly contribution to the podcast, which helps keep us going. And at the moment, through Patreon and Supercast, 30-day free trials are available. So you can test the water, decide whether or not it's for you. And if it is, great. If it's not, that's fine. It's not mandatory. Becoming a patron was actually a listener-generated concept. We never even knew that it was a possibility until someone said, look, I'd like to contribute to the show, but you don't have a Patreon account. And we went, what the? So, that's how it all happened. So we really appreciate the audience coming to our aid. And if you would like to be a part of that, go to our website and check out the details. Now, Fred, something I wanted to quickly mention is that there's going to be a lunar eclipse on Friday night.
There is indeed.
It won't be a total lunar eclipse for us. It'll be 97%. But what I've been told is that the 3% that's not going to be covered by the Earth's shadow, you won't be able to see anyway. So we will get the same effect in Australia. But what surprised me was that this is an eclipse that will be able to be seen all over the world. How is that possible?
Yeah, usually it's just one half. You've sprung this on me, Andrew. I should
know.
bring up my map. I'm not sure. Probably what it means is that the bit you can't see it in is the Pacific Ocean, which is big. If you see what I mean, that's terrible, isn't it? I can't.
No, I shouldn't have sprung it on you like that, but you know what I'm like.
Here we are. Actually, yes. So it is not true that it can be seen all over the world.
Well, that's just creative license on the part of the journalist that wrote the article, I imagine.
No, it's and in fact the Pacific Ocean is right in the middle of it. So it's Australia, Western Asia, half of India, the whole of the Americas. That might be what they were thinking of.
Yeah, well, that's pretty well most of the world.
Yes, most of the world. That's right. No, it's the whole of the Americas and actually quite a lot of Europe as well.
Yeah. So, all right. That's Friday night, our time. You'd be able to check online when you can see it, and it's going to make the moon look like Mars. It's going to turn it red, which is always a stunning effect. Now, Fred, we got some questions. This one firstly comes from Sweden.
Hi, Fred. Hi, Andrew. This is Leo from Sweden. I stumbled upon your show a while back and I've been loving it ever since. I had a couple of questions about planets. Would it be possible for two Earth-sized planets to orbit each other and then in turn orbit a star, making them both habitable? And the second question is, what would happen if we nuked Venus? Could we create a nuclear winter and somehow reverse the greenhouse effect? Thanks for a good show. Take care.
We might get the Russians to look into that second idea. Let's go to his first thing, which was, could you have two planets orbiting each other that would both be habitable orbiting a star?
It's a lovely scenario, isn't it? To think about two Earths, in orbit, and maybe sister planets with interplanetary trade between them. What a lovely concept, straight out of science fiction.
Nuclear war.
It could be. Sorry, go ahead.
Nuclear war.
Well, I was going to say it could be like the rogue planet Phantos. You will not be aware of this, Andrew, because it was before your time. But Dan Dare, Pilot of the Future, in the Eagle comic, which I read avidly as a kid, there was a long series of stories that this is the war between the two sister planets, Kryptos and Phantos, and it's a very complicated and intriguing story, which I haven't time to talk about now. But that's the kind of thing. Twin planets, you needn't necessarily be twin-friendly planets. Is it possible physically? Probably. The planetary formation is a fairly well understood process and consists of this process of accretion. You start off with grains of dust and they stick together, probably first of all by electrostatic attraction, but then they gradually grow bigger and bigger. Gravity plays its part. They turn into rocks. They turn then into eventually into planets by small things colliding and sticking together. They sort of bang each other apart as well. But the overall process is that you form planets. Now, whether that process would allow you to form two identical planets in the same region of a solar system, orbiting each other, I'm not sure, because you might expect. Sorry about that. You might expect the coalescing material to basically to form one object rather than more than one.
Yeah.
So that's one scenario. So what I'm saying is, I think that planetary formation tends to produce unique objects. However, if you've then got a period through which the infant solar system went, like our solar system did, where lots of things are banging into one another, forming, for example, the moon and tipping Uranus off its axis and things like that, then it's possible to imagine a scenario where you might have a pair of planets that interact gravitationally in such a way that they form a stable pair orbiting around their barycenter, their common center of gravity. And so, yeah, it's feasible that might well happen. Pluto, of course, the dwarf planet Pluto, has a moon which is half the diameter of it, called Charon, and they orbit around their mutual center of gravity. So it's almost like a double dwarf planet.
Yeah.
And that's the kind of thing that you might envisage for a planet too.
So definitely possible, Leo. The second part of his question, could we nuke Venus and reverse the runaway greenhouse effect?
I suspect... Well, first of all, you never tinker with a planet's atmosphere. It's always got bad outcomes. Nuclear winter is a concept that was, yes, very familiar to us in the period of the Cold War, because everything was, all about what would happen if. But it's to create a nuclear winter, you've clearly wiped out everybody, because you've damaged the atmosphere to such an extent that you've created clouds of dust. It's basically what happened in the aftermath of the impact, the Chicxulub impacts that wiped out the dinosaurs. It was the reduction in temperature once things had cooled down after the blast that is thought to be one of the reasons why the dinosaurs became extinct. But how do you control it? It's I suspect you would not have even the biggest imaginable nuclear arsenal would not bring the temperature down from 450 degrees Celsius to something that we could live in. So I suspect that whilst it's an intriguing idea, I don't think it's a goer. I suspect the physics doesn't let you do it.
Okay. You're 1 and 1, Leo. Yeah. Your first question had merit. Your second one, dong. But no, lovely to hear from you. Hope all is well in Sweden, although it'll be pretty cold there at the moment, I reckon. It's pretty cold here, though. We're struggling to get out of winter. But thanks for your question. Let's move on to a question that comes to us from the UK. I love Mike's accent.
Hi guys, it's Mike Cupid here from the UK. I'm a massive fan of the show. I know everybody says that, but I honestly do mean it. I've been listening for the past year. I've listened to all the back episodes and I'm bang up to date with everything, and you keep me absolutely fascinated. I've got a quick question on the probability of us finding life on Mars. I was listening to a back episode last week, and Professor Fred Watson mentioned on that episode that by the end of 2021, there's a good chance that we will know one way or the other whether there was life on Mars. Now, we're nearing the end of 2021 now, and as far as I can tell, there's not been any sort of massive breakthroughs. I've had a little read into it, and apparently Mars lost its protection from solar radiation around about 4 billion years ago. So, if, say for argument's sake, there was life on Mars up until about 4 billion years ago, until it started getting blasted with solar radiation, that seems to me like a heck of a long time, 4 billion years, for the evidence to still be moping around on the surface of Mars. If there was life on Mars 4 billion years ago, is the evidence still going to be around for us to find it? And at what point do we stop searching for life and just concede that it's either never been there or we're never going to find it? It seems to me that the only conclusive way for us to work out whether there was ever life on Mars would be for us to find the evidence that there is life. I hope that makes sense. Anyway, I just wanted to get your thoughts. If you want to answer the question, I would be eternally grateful. If not, don't worry about it. Thanks, guys.
Yeah, we don't want to answer the question. We just like your accent. No, Mike, by coincidence, Professor Fred Watson is with us today, so he can answer to the claim that we would know by the end of the year. The other thing I wanted to say to you, Mike, was you say that you're a massive fan of the show and everyone says that. They don't. We get thousands and thousands of hate emails and questions every day. We just delete them.
I never see them.
No, it's
So-
good. I'm glad you like the show.
Yeah. So, Mike, I'm guessing maybe Manchester or thereabouts for that accent. Shoot me down if I'm wrong, but it's lovely to hear from you. And some really interesting questions in there. Let me start with the last one, actually, because Mike is right on the money. Unless we find life on Mars, we will not know whether it was ever there. So it's the same with finding intelligent life in the universe. Unless we find intelligent life, we're never going to know whether it's there or not, because there's so much of the universe.
Yeah.
10 to the power 23 planets or stars with planets around them. And it's a similar scenario with Mars. Mars is a big place. It's got the same land area as the Earth has. And we're still discovering things about the Earth that we didn't know.
Yeah, we found a new rock the other day that we didn't know existed on Earth. I'm serious.
A new type. Yes, I saw
new
that.
kind
I
of
think.
rock.
Yeah, I saw that.
It was inside a diamond.
Yeah, it was predicted theoretically, and this was the first time it had ever been seen. Yeah, I saw that.
Gee, we're geeks.
I know. Never mind. Okay, I'm taking the questions in backwards order here because that's the only way I can remember them.
We'll start the show soon.
Yeah, we'll start the show. After 4 billion years, supposing life became extinct on Mars 4 billion years ago, will there still be traces? Answer, yes. And the reason why I can say that is that the earliest evidence of life on Earth is round about 4 billion years ago. And the geological evidence is still there. Perhaps the most telling formations that depict life are something I actually talk about in Space Warp because it's such an interesting aspect. There are these microbial mats that get laid down by primitive organisms. The microbes form a layer, and then the tide comes in or something happens, and they stay there, but there's sand or something deposited on top of them. Then they form another layer, and you get these layers of microbial mats, which are called stromatolites. And they are well studied, particularly here in Australia. Up in Western Australia, there's some of the oldest stromatolites known. They're about 3.5 billion years old.
Yeah, I think they call them rusty.
We're getting to rusty in a minute. But in particular, stromatolites can be caused by non-biological processes, but the ones that you can pretty well guarantee have a biological origin form features which are known as Mickey Mouse ears stromatolites because they've got waves in them. So I've got a nice little picture that I did of Mickey Mouse ears, stromatolites in the new book. And that's exactly what they look like, Mickey Mouse ears. And so, so it is possible to be unequivocal about the existence of life all those years ago. And in fact, Perseverance is looking specifically for Mickey Mouse ear stromatolites on Mars. Now, they wouldn't, and this comes back to the first part of my question, Perseverance, being run by sober-minded scientists, is not capable of definitively saying, or the scientists are not capable from the evidence that comes directly from Perseverance. They're not able to say definitively that they found traces of living organisms. And that's why Perseverance is doing these core samples in rocks to bring them back home and subject them to the most stringent tests. So that bloke, Fred Watson, who said that by the end of 2021 we might know one way or the other, was talking out of his hat because I hadn't really, it is possible that there might be something that would be staggering enough that scientists would say this represents really strong evidence for the existence of past life on Mars. But it as we now know from following the work of these scientists very closely, it is actually a much more meticulous process. We really need the samples to come back to be analysed to say definitively one way or the other whether there was life on Mars from the samples that may look encouraging.
The other piece of evidence that could probably prove it is teenage Martians slashing the tyres of the Perseverance rover.
That as well. But in fact, The Perseverance mission scientist said something a bit like that. It was something to the effect that Perseverance is not really set up to find present-day life on Mars. It's really looking at ancient life, the possibilities of ancient life. And he said the only way we'd find present-day life would be if something jumped across in front of the camera. Then that would be a turn up for the books.
Well, we know Mars doesn't have any kangaroos because Perseverance hasn't hit any.
Yes, that's right. Exactly.
Same joke applies to armadillos, Tasmanian devils,
yes, it
deer,
does throughout the world.
Whatever you hit in your country. We hit kangaroos.
We do.
I know in other countries they hit other things.
It's tragic as well.
It is. Okay, Mike, I hope that covered your questions about life on Mars. Now, one more thing, and that is a photo we've been sent from our good friend Rusty in Donnybrook, Western Australia. He said he used his iPhone 11 to take this photo of the moon and its crystal ice ring. He did that a couple of nights ago, and he said, I understand that the light of the moon is somehow bent by Earth's cirrus cloud ice crystals at just the right angle, and we see this beautiful ring around the moon. I'm wondering if Fred can explain the phenomenon further. No, he can't, but we'll make it up. It is a beautiful image. It sort of looks kind of smoky with the moon in the centre, and that's the image we've used as the feature of this week's episode on the podcast, so you can see for yourself what we're talking about. But, over to you, Fred. Is he on the money with that?
Yes, he is, of course. The smokiness is actually the cirrus clouds themselves that are very high clouds. And the ring is nicely defined. It's not the clearest one I've ever seen, but it's a really nice one. It's nice when you see a complete ring. It's called the 22-degree halo because the radius from the moon to the ring is 22 degrees, the angle. And that is significant because if you imagine ice crystals, which are exactly the same shape as a hexagonal pencil, but rather shorter, so they're a bit stubbier than a pencil, but they're hexagonal and long, like a pencil is, but made of ice. That's what's causing this. It's crystals like that, which are spread throughout the whole of this cloud of cirrus. And there are all kinds of angles. They're tilted over at any kind of angle you might imagine. It's completely random. But the light passing through them, it actually is refracted. It's bent by the surface of the ice. And what it happens is light passing through the edge of one of these crystals comes out at an angle of 22 degrees from its original passage. And so what happens is that even though these ice crystals are bent they're distributed at all kinds of random angles, it's the ones that pick up the light from the moon and bend it back to your eye that you see, and that naturally forms a circle. Because it's always that 22-degree angle that they're bent through. No matter what angle the ice crystal is, it's being bent through a 22-degree angle. So it's only the ones that are correctly orientated that cause the light to come back to your eye. The other ones, it goes into somebody else's eye, basically. And that's why you see the circle. And the other thing that you might notice, anybody looking at this photo of Rusty's, is that there is a slight tinge of red to the inner edge of the ring. And that's because the ice crystals are acting like a prism. They're actually breaking the light up into its rainbow colours. It looks a little bit bluish on the outer edge, not so well defined, but often, particularly if you see one formed in sunlight. So the sun does exactly the same thing as the moon.
Yeah, I took one a few weeks ago of an ice halo around the sun, and it was a beautiful thing to see. It's the same effect, is it?
It is exactly the same effect, yes, just during the day rather than during the night. But often the red inner edge is much easier to see in sunlight because the ring is brighter. But yeah, very nice photograph and the correct interpretation, which you've introduced your picture with, Rusty. So
and a very different effect from a pollen corona.
Yeah, the pollen coronas formed by a different phenomenon. It's diffraction of light. Yeah,
I took quite a few pollen corona photos this year.
As well. Yeah.
Interestingly, I got perfect images of them with an iPhone, but I could not take them with my digital camera.
Expensive camera, I know.
Yeah, I was quite stunned that it couldn't do the job. It tried too hard to focus on the sun, so I couldn't get the halo. Yeah. So, Rusty, I suspect that the phone is probably the better option in some circumstances because they've got such great cameras in them these days.
Yeah.
But thanks for sending it through and sharing with everybody because they can all have a look at it on our cover page for this week's episode. Nice to hear from you again, as always, Rusty. And everybody who's sending questions and contributions to the show, we really appreciate it. Thank you. And, of course, if you would like to contribute to Space Nuts via our website with an audio or text question, you can do that, spacenutspodcast.com or spacenuts.io. We'd love to hear from you. Don't forget to tell us who you are and where you're from so that we can share it with the entire Space Nuts world. And don't forget to visit the website for all those other reasons. Keep you up to date with astronomical news and visit the shop and get yourself one of Fred's calendars while you're there. That'll set you up for the entire year next year. Although I think he did it with the Julian calendar. Trying to stay on side with the Russian.
No, that's right.
That's what it was. Okay. Thank you, Fred, as always. It's been a great pleasure.
We'll see you next week, I hope, Andrew. Take care and have a good week.
You too. Professor Fred Watson, astronomer at large, we thank him every week for coming in and telling us all these amazing things. And to Hugh back in the studio, keep on doing whatever it is you do, Hugh. We love you for it. And from me, Andrew Dunkley, thanks for your company, and we look forward to catching up with you again next week. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.